after we did our workshop last year. So here are our names and the college affiliations. So we are going to present the simulation and modeling warfare in a differential equations class. So the outline, so we are going to do an introduction of our presentation, and Kyle is going to do a demonstration of the simulation data collection. So now we will look at how to construct the models and then the solutions. Also specifically, we will also talk about the, what the activity done in the classrooms last fall, or some suggested alternatives by Justin. This Lanchester's equations apply to model the warfare. One of the important wars in history is the Battle of Trafalgar. So this war it started and completed in one day. The Admiral Nelson defeated the combined French and the Spanish fleet in a few hours of the battle, and then the British fleet were outnumbered and outgunned by the French and the Spanish fleet, but Nelson applied a divide and conquer strategy, then that defeated the enemy, and then so destroying 19 of 33 enemy ships, and then no British ships were lost. But both sides have some seamen lost in the battle. So this battle, the importance of this battle is that it's prevented Napoleon to plans to invade England again. And so next, Kyle is going to show us how we collect data to do the modeling.
Thanks, Lee. My doesn't look like I'm able to share my screen.
Do I need to unshare?
Yeah, I think
you'll need to stop sharing, Lee.
Okay.
Perfect, thanks. Yeah, can everybody see that all right? Okay. So yeah, so I'm going to talk a little bit about the data collection that is going to help us put together our model, in particular finding the parameters that will go into our warfare model. I don't have actual M&Ms with me, so we'll just use this this example that we have on this slide here. But what we're going to do is we're going to use 12 M&Ms of both colors, red and blue, to simulate rounds of battle. So the way that this is going to work is that if you have an M facing up, that's going to represent a vulnerable soldier or ship on one side, and then if you have a blank M&M, that's going to be an attacking soldier. Okay, so what we're going to do is we're going to put the 12 M&Ms on both sides in one cup. We'll roll them, and let's suppose they came out on this left-hand side in this manner. Okay, so what we're going to do now is count the casualties in this round of battle. So I'll try to annotate here. One casualty on the red side. What we're going to do is match up every vulnerable soldier on the red side with any attacking soldiers on the blue side. So in that top left corner, that's going to result in one casualty for the red side, right? So vulnerable for red, attacker for blue. We're going to keep doing that. We've got another vulnerable red with an attacking blue soldier here that I just circled. That's going to be resulting in a casualty for red. And then you keep going through this process. Okay, so we should have, I believe, 3 more. Here's one pair of vulnerable with an attacker. Here's another pair here. There's another red casualty. And then I think there's one more, yeah, up at top here. Okay, so we've got 5 red casualties here in this particular battle because we've got 5 vulnerable soldiers for red that are attacked by 5 attacking soldiers on the blue side. Okay, so this would result in 5 red casualties in this battle. And if you look there on the diagram on the right-hand side, it matches up all the blue vulnerable soldiers, those blue M facing up with an attacker on the red side. So we're going to have 5 casualties for the blue side. Okay, so what you would do in the classroom, or potentially what you could do, is you could have each individual student run, say, 10 of these 12 on 12 battle simulations. And what this is going to do is give you a little bit of a feel for the fighting power of each side, like how skilled the red side is as opposed to how skilled the blue side is in terms of creating casualties for the other side. Okay, so let me see if I can clear this annotation and go to the next slide. Okay, so yeah, let's suppose that this is an example of collecting 10 different rounds of 12 versus 12 on the red versus the blue side. And it's just tallying up all the different casualties in each of those 10 mock battles. Okay, so if you look there, I'll focus on a few pieces of this. If we look down in this mean row right here, what that represents is the average number of casualties each side has suffered in these mock simulations that we have done. So on average, red lost 5.9 soldiers out of their 12, and blue lost on average 4.9 soldiers out of their 12. You could expect them to be fairly, close. There's no reason why the red side, in terms of the M&Ms, would create more casualties into the blue side. So they should be fairly close. And Justin will talk a little bit about, extending this, not having just 12 and 12 on each side, and how that might change the mean or the parameters that show up. Okay, the other thing I want to focus on here is these 2 parameters in that last row. We've got the rho and we've got the beta. Rho refers to, really is referring to the red's fighting strength. Okay, so it's the average number of blue casualties rather, divided by the number of red units. So that refers to the red's fighting strength, and Justin will talk about how that goes into our mathematical model. And then beta represents blue's fighting strength. It's the average number of red casualties divided by 12, the number of blue units in each battle. Okay, so I'll hand it over to Justin and stop sharing my screen.
All right, so yeah, at this point now, your students have ran their simulations, they've collected their data, which you can pretty much easily do in like a Google spreadsheet if you want to do it kind of all live. And like Kyle was saying, that rho parameter really represents like the red fighting strength, or the other way you can think about it is the number of blue that are lost per round of fighting, and same thing with the beta. And so in class, you could now at this point challenge your students to develop their own sort of equations that would govern this process. So again, just writing out in detail what rho and beta are, and hopefully with some discussion and whatnot, and maybe some trial and error, the students would arrive at, okay, the rate in which the red army loses units per round of fighting would be minus beta times how many blue units there are. So again, beta represents how many red are taken out per round, and the minus would represent that decrease that's in there after every round of fighting or time unit that you're talking about. And also same thing with the rate of change for blue, right? It's going to be based off of that rho, how the fighting power of red, and then again multiplied by how many red there are, and that minus would give you that decrease. And so collectively, these two, the system of differential equations together, these are known as the Lannister's equations. And you could kind of extend these as well by adding other parameters, but this is the traditional system that you work with. So I will drop out of sharing, and then Lee will pick up from there for a few more.
So from the Lanchester equations Justin introduced to us, if we eliminate the parameter t, then we can find an implicit solution that is the relation between R and B, where R0 and B0 are the initial at time 0, the initial the number of soldiers were in each side, and the rho and the beta, both Justin and Kyle already represent, that's the firing power of each side. Now, to do some algebraic just rewriting, and then we can find out this, we can write it this implicit solution. And then the right side is actually is just a constant C. And so depending on the C, if it's 0 or greater than 0 or less than 0, that will determine if and both sides will end up with a drop, or if C is greater than 0, that means the is R side wins, and if C is less than 0, that's blue wins. So basically, this is an equation for the solution curves are hyperbolas. Now, if we just do some sensitivity analysis based on the solution implicit equation, and then we find out that if rho and beta is the same, that's the firing power. If they're the same, then it's the side with more soldiers to begin with will win. And if the firing powers, if the initial number of soldiers are the same, then whoever has the greater firing power is going to win. So this actually verify our intuition. Now, if the red side has more soldiers and more firing power, then obviously red is going to win. And if blue side has more soldier and more firing power, then blue is going to win. But in the case of then, if red has more soldiers than the blue, but less firing power, then that depends on the ratio. So basically, we can see that the number of the firing, the numbers and the fire powers are unequal in the opposite sides direction. So, and then it's more important to have more soldiers to start with, because if the red has twice as much increased the number to be twice as is 2R0, then the blue side, if they want to bring up to the same level, blue has to, the firing power beta has to be 4 times as much as before, just to bring up to the same level as before. So that's the sensitivity analysis of those parameters. So we can also find explicit solutions for both R and T, both R and B as a function of T. There are 2 ways to do it. First, we can just use substitution, and then this system can be actually converted to a second order constant coefficient differential equation, and this can be solved. That's what we covered in differential equation. Now, also you can use the matrix method solving as the system, and here is the explicit solution here. Okay, then next, I will stop share here. Next, Lisa is going to talk about what we do in the classroom, what she did in the classroom. See, stop share.
All right. So for the remainder of the talk, each of us will just take some time to talk about our own experiences. So we all participated in the Mind Worksheet Shop in the summer of 2021, so just last summer. And then many of us implemented this particular modeling activity into our course. So we'll give a little bit of information about the setting in which we're working, and then the adaptations that we made in order to fit the needs of our classes. So for myself, I'm currently a visiting assistant professor at Macalester College, which is a highly selective liberal arts college in St. Paul, Minnesota. I arrived at Macalester in the fall of 2020, and for my first year, I taught my differential equations course as a fairly traditional course focusing on kind of hand computation in theory. But as I settled into my department, I learned that we have a very heavy emphasis on both end of semester projects and the use of technology inside of our courses. And additionally, many of my students are double majors or non-math majors. And so they have outside interests. As I inherited the course, we had kind of a schedule set aside so that students had a 2-week project, a writing group project at the end of the semester. And many of my students wanted to draw on their other majors to do things like study differential equations in the context of environmental science or physics. And they struggled with their projects in that they didn't always have experience from the classroom setting for building models and understanding other scientists' models. So we do have an upper level math modeling course at my school, separate from differential equations. And so my goal was not to turn differential equations into a modeling class, but just to add a little bit of insight so that students could kind of complete this project in areas of their interest. So I did use this simulation with the M&M warfare, and I made 2 modifications to meet the needs of my class and my students. First of all, I was teaching during COVID, of course, so we weren't allowed to eat in the classroom. I did give my students M&Ms to take to go with them when we were done with the modeling activity, but so as not to tempt them, during class, we used poker chips for our data collection. I put a sticker on the poker chips to represent the vulnerable chip or the vulnerable side in place of the M on the M&Ms. And the stickers and poker chips allowed me some flexibility. So I was actually able to alter the fighting strength of the forces, theoretical fighting strength, by adding stickers onto 2 sides of some of the chips. So those chips would always be vulnerable chips. I didn't tell my students that I did this, and they didn't check. They weren't that curious at the beginning, but they did notice at the end that our parameters didn't match what would have been the case if I had just put 1 sticker on the side of each chip. I wanted to make this modeling activity something that we could do in a single hour-long class period. So I did make the theoretical fighting strength of each of my group's forces the same, but if I were to do this modeling activity in a situation where we didn't have an hour-long time constraint and weren't trying to collect a data set, I might give each group a different theoretical fighting strength of their battle and allow them to compare with multiple groups. And then the second thing I did is, as I mentioned, technology is really important inside of our math classes. And because of this, I incorporated some Mathematica into the activity so that our students could engage in this way. Our students begin using Mathematica in Calc 1. So they've used it in Calc 1, Calc 2, and Calc 3, which means they already have basic skills to do things like plot functions in Mathematica. And this makes incorporating Mathematica and technology into the modeling activity fairly easy. I'm going to show 2 of the things that I asked my students to do. The first one is, so we collected rho and beta using our standard data techniques, but I asked my students to build either a stream plot or a vector plot to draw some slope field type figures to represent the solutions so that they could see what would happen given different initial conditions. My students at this point were already familiar with drawing slope fields for single ODEs, but drawing these slope fields for systems of differential equations was new to them. So I gave them some brief instructions, but again, they have the technical background already to be able to pick this up in just a few minutes. And then the second thing that we did is we used the built-in differential equation solver DSolve in Mathematica to find explicit solutions to the differential equations that they came up with, or the system of differential equations. And after they came up with the system of differential equations, they were able to use the plot feature in Mathematica in order to plot their solution curves and compare in a different way what is happening between the two forces. I think I'll stop and send it over to Kyle.
Since, okay. All right, yeah, so just a little background about the adaptation that I am going to talk about. So similar to Lisa, I started at my current university, Worcester State University, in fall 2020. And at Worcester State, we also offer not only a differential equations class, but a math modeling class. So they're very small classes. I had 5 last semester, and then I have 4 this semester. And they're strictly math majors that are taking these classes. And in this math modeling class in particular, where I'm going to talk about, or where I used this activity that I'm going to talk about half of those folks are going to be secondary ed. In other words, they're going to be future educators. Okay. So I used a discrete model. So on the title there, talk about discrete warfare. So I used a discrete model, in other words, difference equations. So in that math modeling course, we talk about discrete models, these difference equation models. We do get to differential equations and do some statistics as well. But the first part of the class is discrete models, so difference equations types of models. Right. So what I had the students do is I had students simulate an actual full war. So they would go through 2 sides, red versus blue, and they would simulate a full war until one of the sides lost. Okay, and I used, similar to Lisa, I used chips instead of M&Ms. So I used actually not red and blue, but red and yellow, those counter chips, and a 6-sided die to determine the casualties in each round of battle. Okay, so this is a discrete version. Difference equations, if you're not familiar with, it's just really a discrete version of differential equations. Okay, so like I said, I used not only red and blue chips to represent the soldiers in the war, but also I introduced some probability into the simulation. So the way that these simulations would work, I would have the students on each side. We would have in one round of battle on each side, each member of the team, each soldier would roll a die. Okay, and if that soldier on, say, the red team rolled a 1 or a 2, there was a casualty on the blue side. Okay, so really the fighting strengths were given to the students right off the get-go, right? There was like a 1/3 chance that the blue side would suffer a casualty from the red side. Okay, so you would do this for each and every member of the red team, right? Every member of the red team, every red soldier would get a chance to roll. And if that red soldier got a 1 or a 2, we would eliminate a blue soldier, okay? Before we took away the blue soldiers, blue got a chance to roll. So same deal, each member of the blue team would get a chance to roll. If that member got a 1 or a 2, that would result in a red casualty. Okay, a casualty for the other side. All right, so this would represent one round of battles, right? This is one battle, but I would have the students continue on until one side lost all of their troops. In other words, all of the chips were removed for either the red or the blue side. Okay, so it was a little bit of a different flavor because we didn't do a data collection to get the fighting skills, those parameters beta and rho that Justin had talked about before. Those were given. It was really like a 1/3. 1/3 was what rho and beta were for both sides, based off of this activity that we were doing. Okay. So I did have students do that activity of running an entire war until one of the sides lost. And when I had them do that, I wanted them to think about kind of where the parameters would show up in the mathematical model, in that difference equation model. Okay, so students, I had them try to create a model based off of that simulation that they were doing, right? They should have had parameters of 1/3 for both rho and beta in that case, based off the rolling of the die. I also had them change up and say, okay, what happens? How could we change the game a little bit if, for example, red had better fighting skill than blue, right? I wanted them to tweak the parameter in the model, but also tweak the game in a sense of maybe, okay, if red has better fighting skill than blue, then maybe if on the red side they roll a 1, 2, or a 3, that would then result in a casualty for blue. Okay, so this hands-on activity tried to get them to see where those parameters were going to show up in their mathematical model that they would create. Okay, so since these are difference equations, we could just use like Excel or Google Sheets to once the students built their models to get the numerical solutions. So Google Sheets I use all the time in these classes, and I think for future educators, it's something that high school students could handle, working with Google Sheets and things like that. So it's nice for them to get exposed to that. All right, maybe a possible extension, just thinking about into next semester, like how can I maybe incorporate like reinforcement troops into the model, things of that nature. Okay, so I'll pass it over to, I believe Justin is going to go next.
Actually, Lee is.
Yeah, I will.
Lee?
Yeah, so just like Lisa and Kyle, I also taught this a mathematical modeling course in the fall and at the Citadel for the math juniors or seniors. And now that course although it's not a differential equation course, but differential equation course is a prerequisite of the course. And in this mathematical modeling class, about 50% of the models using the differential equations or system of differential equations. So for this particular line charge equations, we not only it's a very good model and topic, because not only can solve it, teach them to solve it by hand, but also you can use the technology. We use the Excel and also MATLAB to and also model the Trafalgar War to understand why the Admiral Nelson's divide and conquer strategy worked and help the British side to win. So first, so we used this 27 ships for British side, and if it's a direct direct attack, head-on attack, then they would have lost. Because remember that R0 and B0, if the one, they basically have the same firing power, and French and Spanish has a few ships, has maybe more powerful weapons, but they basically have the same firing power. So whoever start with less ships, according to the model, is going to lose. And then so if they do a head-on attack, then they're going to lose. That's after stage 11, then only 2.67 of the 27 British ship would survive, and 18.25 4 of the French and the Spanish ship would survive. So here is the putting the Excel here. So that's if we assume those is 0.1 here, then that's what we have it here. And then now. So this is assuming they have a head-on attack. Now, but actually Nelson used the divide and conquer strategy. So divided the British fleet in fighting 3 battles, A, B, and C. So the first one is 13 of the 27 attack 3 of them. Now obviously they have more British. Every battle you can see they have more to start than in every battle they won. Battle B here, they used the surviving 12.6 combined with the remaining 14 standing to attack the French, which at the end of the battle, A is only has 1.07 left, and then combined with the 17 of the 30 standing, and British still have more. Then in the at the stage 16 and 19.27 British ships survived, but only 1.44 enemy ships survived. Then Battle C, British survived using the 19.27 ships to attack all the remaining of the 14.44. And then if after the stage 18 and 12.58 British ships would survive, and only 1.51 enemy ships survived. Now, the battle did not go that long, as I mentioned earlier, only a few hours, maybe 5 hours fighting. So here is the, you can see that you put it in the each battle in the Excel sheet. So here it's also just, now, if you put using a technology like this, now you can also just if you have to change anything, 2733, that's the initial R0 and the B0, and then those firing powers, you can just like if the head-on, if the head-on this attack, if say if this this change from 0.0 to 0.4, that's going to change the outcome. So you can see that then French would have lost, and the British which would have won, even if British started with 27, French with, so here we assume they have the same firing powers. So the head-on would be British would lost. And then for each battle A here, you can also see the simulations and then how this is end up. And one interesting thing is this battle is occurred on October 21st, 1805. And now I taught this class, and this model happened to be introduced in also just October 20 something. One of my students thought I intentionally planned this way, but I did not. It's just if you're teaching the file, and yeah, and introduce this one, and it's interesting that it's like yeah, it just happened to be in the October, and then yeah, it's a very fun model to teach your student. Not only they have hands-on experience, but also teach the differential equations too. Next, Justin will show us how he thinks he should teach the model.
Yeah, thank you. So yeah, just try to think of different ways that you can modify this for your class. So for me, I teach at a small liberal arts college. We only have a we have a differential equations course and a PDs course that we run irregularly. And we have a lot of double majors in chemistry and physics, but we do have some math ed majors. So these sort of activities are good to give those students like hands-on sort of things, different ways of visualizing it. And so in addition to like all these other modifications you can make to like create unequal fighting forces, kind of a quick solution would also be to just change the number of M&Ms so they're not equal. And so unfortunately, I was kind of locked up at home when I was preparing this, so I ended up using coins to kind of simulate a few of these rounds, but I ultimately wrote some code to do this. And so what this table is just kind of like, I think I did about 1,000 rounds for each of these just to see what they would approach. So I held the blue M&Ms fixed at 12, and then I increased the number of red M&Ms, which are listed here in this column. So at 13, they're still pretty close to what you would expect initially. I think the numbers are about 0.42 or so. But as you increase up to like 21 red, rho drops to about 2.8, and then the beta increases to almost 0.5. So just by changing the number of M&Ms, making them not equal, you can also replicate this sort of like uneven balance in fighting power. And it looks like as you push red higher and higher, the beta maxes at about 50, and then rho tends to about 10. With that, I think that's the last of it. Yeah, because those are our references. So thank you for attending.